Hello, dear students. I hope you studied well the previous lesson and that you are ready for today's lesson. It's about motion. What's meant by motion? Well, motion comes from movement. It's when you change your place or position from one place to another, like when you travel from Cairo to Alexandria, or when you walk, run, play, or even ride your bicycle. Yes, that's right, as you can see in the picture, or even walk your dog. Let's learn more about the motion from this video. We have learned from the video that whenever my object changes position with time, this is called motion. Let's have a look in our car here. When the car moves from point A to point B, it's said that the car changes its position. But of course it takes time to do this. So changing my object's position with time, this is called motion. My car moved in a certain direction from point A, which is the starting point, to point B, which is the ending point. The distance covered between the 2 points, the starting and the ending point, is called displacement, because the car moved in a certain direction straight from A to B. Let's have a look on this picture to understand more about displacement. If my ant moves a distance from A to B, this means my ant will move in a certain direction straight to point B. This is called displacement. But when my ant take different directions and different routes to go from point A to point B, this is called the ant moved a distance. So displacement, it's the distance at which an object moves away from its original position at any moment in certain direction. So let's say you covered a distance of 2 meters in 1 second, while your friend covered the same distance in 3 seconds. Which one of you is faster? Yes, that's right. It's you, because you covered a displacement of 2 meters in 1 second. But he covered 2 meters in 3 seconds. This means his speed was slower than you. So I can know the speed of the object by knowing the distance it's covered in how much time. Let's have a look on our car here. The car needs to make a displacement of 12 meters from point A to point B in 4 seconds. And then it made another displacement of another 12 meters, which is equal distances, in another 4 seconds, from point B to point C. This means my car covered equal displacements in equal periods of time. So the speed of the car changes? No, because if it changes, this means that it would cover the 12 meters in 2 seconds or 3 seconds or 5 seconds. But it actually covered the other 12 meters in the same 4 seconds. So the speed of the car is constant. Constant means it has a uniform velocity. Velocity means speed, but in a certain direction. So looking at this example, my car covered a displacement of 12 meters from point A to point B in 4 seconds, while it covered a displacement of 20 meters in the same 4 seconds from point B to point C. This means that the speed of the car is constant. It's moving with the same speed from point A to point B and from point B to point C? Of course not. Because if it's moving with the same speed, this means that my car would have covered the displacement of 20 meters in more than 4 seconds. So my car covered an unequal displacement in equal periods of time. This means that the speed is not constant, it varies. From B to C, my car speeds up. The speed becomes faster. So to say the displacement covered from point A to point C by my car, it uses a non-uniform velocity. And because it's covering in a certain direction, which is displacement, so my velocity is the displacement covered by an object in a unit time. So we have come to a conclusion that I have two types of velocity, a uniform velocity and a non-uniform velocity. The uniform, my speed is constant and it doesn't change. But for the non-uniform, my speed varies. So the uniform, the speed of the object that covers an equal displacement at equal periods of time, because my speed is constant. But because my speed is not constant in the non-uniform velocity, of course I'm covering unequal displacements at equal periods of time. To graph the movement of the object with time, we use a graph motion. The graph motion is represented by displacement on the y-axis and time on the x-axis. It shows the motion of the object, how it moves, and the speed of it. If my object moves an equal displacements in equal periods of time, like shown in the first graph, 5 meters in 5 seconds, another 5 meters in another 5 seconds, this means that my object moves with constant speed, which is a uniform velocity, and the motion is represented by a straight line passing through the origin. But if my object is moving an unequal displacement in equal periods of time, this means that my speed is not constant. So it's said that the object moves with a non-uniform velocity. Looking at the second graph, you'll find that it moved 5 meters in 5 seconds. So there is a slightly straight line passing through the origin. But then it moved 15 meters, which means from 5 to 15, another 10 meters. 10 meters is moved in 5 seconds, so unequal displacements in equal periods of time. The motion is represented by a curved line passing through the origin. But in the third graph, you made a displacement until you reached 5 meters and then stopped moving. Stopping moving, this means there is no speed. No speed, this means velocity is 0, and your displacement is fixed because the object is at rest. You stopping doesn't mean that the time stops. The time still passes. So you have a displacement of 5 meters with time passing. This means that the motion is represented by a straight line parallel to the time axis. These three graphs represent the motion of the object. Now let's have a look on these planes' motion. Which plane is faster? Yes, that's right, it's plane A. Now which plane is slower than plane C? That's right, it's plane B. Now observe carefully. Plane C is faster than plane B. Yes, but it's slower than plane A. Excellent, I love your observation. So you said that C is fast relative to B, and it's slow relative to A. So according to other planes, you decided that plane C is slow or fast. in motion according to your observation. So the motion is relative to the observer, which is you. You observe the motion of the plane. Either it's fast or slow, and you decide it's fast or slow according to other planes. This is called relative motion, where you decide the motion of an object is fast or slow relative to another object, moving or fixed. To understand more about relative motion, let's have a look on this video.